Hello. In this video, I'm going to explain problem 9 from the 2012 F=ma contest. We have a uniform spherical planet with radius capital R, and acceleration due to the gravity at its surface being g, and we're asked to find the escape velocity of a particle from the planet's surface. So first, let's talk about escape velocity. What is escape velocity? So it's the minimum speed such that if a particle is launched at that speed, it will escape, hence the name escape velocity, it will escape the gravity of the, planet or star or whatever, without any extra, push. So, for example, you do not need to keep supplying it energy with an engine or anything like that, and it'll basically never return, assuming that it's uninterrupted, of course. So, how do we calculate something like this? Well, we know that the gravitational potential energy, if we have two masses, m1, m2, then the potential, or let's call them big M and little m, to be, more in line with this problem. So m and we have little m. Then the potential energy will be negative big M little mg over r. So let's say this mass m is on the surface, and this has radius r. Then we know that in order to get escape velocity, we need the total energy to be at least 0. And the reason is that the potential energy at infinity is actually 0. And so what that means is that if the total energy were greater than 0, then this mass could go out to infinity, or greater than or equal to 0, I should say. If total energy is greater than or equal to 0, then that means that you can achieve going to 0, and thus you would get the planet escaping, or excuse me, the object escaping from the planet. So what is the minimum kinetic energy for this to happen, since the total energy is equal to kinetic plus potential? Well, the kinetic energy is, of course, 1/2 m times v escape squared, and so that has to equal negative u, and so that equals little m big mg over r. And so what we see is that we can cancel little m, and so v escape is equal to the square root of 2 capital Mg over r. But if you look back at our problem, they didn't ask us about capital G, they asked us about little g. Well, we can fix that without too much trouble. Remember that what even is little g? Well, it's the acceleration of gravity at the surface. But using Newton's law of universal gravitation, we know that the gravitational force is mmg over r squared. This is m, this is little m. And though that will equal mg when you're at the surface or very near it. And so we know that g is just equal to m times g, big M times g over r squared. And now we know that v escape is equal to the square root of 2 mg over capital R. And so we can figure out how to incorporate the expression for little g. We can see that that's just equal to 2 times little g times r. Since g is equal to big M times g over r squared, we just need an extra factor of r for it to work out. And so we go back, and we indeed see that the answer is right here, the square root of 2gr. And we're done. All right, I hope that was helpful, and thank you for watching.